Hello everyone, welcome back to the channel. For today, I would like to talk about nuclear physics, and I will focus on the subtopic of nuclear energy. This lesson consists of one learning standard. So, I hope at the end of this video, you will be able to communicate about nuclear reactions. There are two types of reaction, which are nuclear fission and nuclear fusion. Before we start, let me introduce you the outline for this video. We will start with the nuclear reaction as the introduction. And then we will focus on what is nuclear fission and what is nuclear fusion. After that, we will see the application of nuclear reaction. And then, before we end, we will test our understanding about this subtopic. Now, let we start with nuclear reaction. Nuclear reaction is a process which the nucleus of an atom is changed. There are two probabilities of changes, either by being split apart or combined together with the nucleus of another atom. Nuclear reaction divided into two types. First, nuclear fission. Second, nuclear fusion. After this, we will go deeper and see the difference between both of them. So what is nuclear fission? Nuclear fission is the process of splitting a big and heavy nucleus into two or more smaller and lighter nuclei. During this process, it releasing a large amount of energy. I will show you a video on how nuclear fission occurs. Let's watch it together. So, as you can see from the video, this is the example on how nuclear fission occurs. A uranium-235 is bombarded by a neutron. Then, an unstable nucleus is produced. We call it as uranium-236. So far, nuclear fission seldom occurs spontaneously. In this situation, spontaneous means fission reaction without initial neutron absorption. Normally, nuclear fission occurs when the heavy nucleus is bombarded by a neutron. This situation of neutron absorption is called induced fission. After that, unstable nucleus will split into two stable nuclei, which are barium-141 and krypton-92. During this process, 3 neutrons are also released. But why they release 3 neutrons here? Now, let's focus on the neutron. In the beginning of process, 1 neutron plus 235 neutrons are equivalent to unstable nucleus that has 236 neutrons. Then, when unstable nucleus is splitting into two nuclei, it produces barium that has 141 neutrons, and krypton that has 92 neutrons. Adding up the total right now is 233 neutrons. So that's why it must release another 3 more neutrons in order to balance the equation of uranium-236. This kind of nuclear fission reaction also can be represented by equation. As you can see from the equation here, one uranium-235 bombarded by one neutron. It produces an unstable nucleus of uranium-236. After that, it splits into barium-141 and krypton-92 and release 3 neutrons as well as a large amount of energy. In short, you can write the equation like this. Okay, now let's move on to nuclear fusion. Nuclear fusion is the process of combining small and light nuclei to form a bigger and heavier nucleus. During this process, it releasing a large amount of energy. I will show you a video on how nuclear fusion occurs. Let's watch it together. So, as you can see from the video, this is the example on how nuclear fusion occurs. 2 hydrogen nuclei combine to form deuterium. Fusion is much more difficult to achieve than fission. It is because the hydrogen nuclei repel each other. Therefore, the nuclei must be heated to a very high temperature. So, it will have enough of kinetic energy in order to overcome the repulsion between the nuclei. Okay, based on the example of nuclear fusion just now, this is the equation. 2 similar of hydrogen 1 are combined together. Then it is produced a bigger and heavier hydrogen 2, which we call it as deuterium nucleus. According to the radioactive decay from your previous knowledge, this process releases 1 beta particle and 1 gamma ray, both of them also known as positron and neutrino respectively. On the other hand, if this process is further and further continuously, it can produce more different types of final product. For example, first, when the deuterium is combining with another hydrogen 1, it will produce helium isotope. Second, when there are 2 helium isotopes is combining together, it will produce helium-4, which is bigger and heavier nucleus. It also releases 2 hydrogen 1 and a large amount of energy. Now, let's move on to the application of nuclear reaction. First application is Sun gets its energy from the fusion of hydrogen nuclei inside it. This picture shows the Sun's layer from the core to the outer layer. Sun's fusion occurs when hydrogen nuclei combine to make helium and release energy. This process and the energy are produced in the Sun's core. This reaction can't be happen anywhere, but it can only happen at incredibly high temperature and pressures. Temperature of sun's core is very high. It is about 50 million degrees and more. That's why nuclear fusion takes place at sun's core, and sun gets its energy from this process. Second application is a hydrogen bomb used the principle of nuclear fusion for its design. This picture shows 4 phases on how a hydrogen bomb works. As you can see the design here, there are a boosted fission primary at the top, while a fusion secondary at the bottom of hydrogen bomb. So, in the first phase, by fires in primary, chemical explosion will compress fission fuel into supercritical and initiate fission. Second phase, the primary emits X-ray which then reflected by casing and irradiating the polystyrene foam. Third phase, polystyrene foam becomes plasma and start compressing the secondary. The fissionable spark plug begins to fission. And at the fourth phase, secondary part compressed and heated. Then the fusion fuel ignites. Now let's try your understanding. Ready? Question 1. Fill in the blank by choosing the correct answer. Fission is the process of ... a big and heavy nucleus into 2 or more smaller and lighter nuclei. So, is it ... is splitting or combining? The answer is splitting. So you must remember, fission is the process of splitting. Question 2. You also need to fill in the blank by choosing the correct answer. Fusion reaction normally occur at very ... temperature. So, is it ... is low or high? The answer is high. So you must remember, fusion reaction occur at very high temperature. Okay class, that's all for today. So I would like to thank all of you for watching this video. I hope we will see you again. Bye!